So we have this thing called the derivative, and we said it tells us all this really cool, interesting stuff. It tells us the slope of the tangent line, it tells us velocity, it tells us rate of change, but we're going to need to be able to find derivatives in order to use those interpretations. And that's what we're going to talk about in this video, is how do we find derivatives? Now, we define the derivative. We said f prime of x is equal to this big, ugly limit statement over here. It's kind of long. It looks complicated. You can, if you'd like, jump headfirst into that limit statement and try to do everything at once. I think that that can feel pretty overwhelming, and it's pretty easy to make a mistake that way. So rather than try to jump in head first and do everything at once, I'm going to break this up into a 4-step process. I'm going to break this big limit statement down into 4 smaller, more manageable pieces, and I think that makes this process of finding derivatives this way a whole lot easier. So step 1 says to find f of x plus h and simplify it. So I'm just going to start with this piece right here. F of x plus h, you'll want to simplify it, FOIL, distribute, combine like terms where you can. After you've simplified it, there's nothing more you can do. Then we'll move on to step 2. Step 2 says subtract f of x from step 1. So I'm going to subtract f of x from what I found in step 1. And you'll see now I have the whole numerator. And again, you'll simplify that as much as you can. Combine your like terms, do whatever you need to do. Again, you'll end up at a point where there's nothing more you can do to simplify it, so we move on to step 3. Step 3 says, now take what you found and divide it by h. So take what you found in step 2, divide that by h. And once again, you'll try and simplify that as much as you can. In particular, for this step, your goal is to cancel this h. You'd really like to cancel that h. And we'll see a few different ways that can happen. You should get to a point where you can cancel that h, and then finally, step 4 says now take the limit as h approaches 0 of what you found in step 3. And you'll notice over on that right-hand side, I have everything highlighted at this point. After that, I'd be done with the problem. I have that whole limit. I just have broken it down into 4 smaller pieces rather than trying to do everything at once. So this is a way to break these problems up a little bit. The students that have the most success finding derivatives using this method all tend to use this 4-step process. So I highly recommend that you use this rather than trying to jump in and do everything at once. If you remember back to section 2.1 when we talked about limits of difference quotients, these 4 steps should feel really familiar. So if you did the practice back in section 2.1, it should be a little bit easier for you this time. So let's jump into it. Let's actually try to find a derivative here. Example 2 says we have g of x equals x squared minus 2x plus 1. We are going to use the 4-step process to find the derivative g prime of x. So this problem, and these problems in general, tend to take up a lot of room. I'm just going to make sure I use as much room as I can. I'm going to start with step 1 here. I want to find g of x plus h. So I'm going to look at my function g of x. Everywhere I have an x, I'm going to take out that x and replace it with x plus h. So I'll have x plus h quantity squared minus 2 times x plus h plus 1. So I've plugged in x plus h. Now we have to simplify this. So x plus h quantity squared, that really means x plus h times x plus h. We'll FOIL that out in the next step. The negative 2 we can go ahead and distribute, so we'll have minus 2x minus 2h, and then plus 1 at the end. after we FOIL x plus h times x plus h and simplify it, we should end up with x squared plus 2xh plus h squared minus 2x minus 2h plus 1. We ended up with something pretty long here. This looks pretty complicated, but if you look at it, there's nothing we can do to simplify this. There's no like terms that we can combine, so at this point, we're ready to move on to step 2. So step 2, we'll do that in a different color. Step 2 right here says I'm going to take what I found in step 1, which was g of x plus h, and I'm going to subtract my function g of x. So I'm taking what I found in step 1, which was x squared plus 2xh plus h squared minus 2x minus 2h plus 1. And I'm going to subtract my original function, g of x. So subtracting x squared minus 2x plus 1. Parentheses are going to be really important here because I want to take this minus sign and distribute that to all 3 terms of my function, of my g of x. The way I do that, I always change that minus sign to a plus sign and then just change the signs on the inside of those parentheses. And what we should have here is we should have some like terms that we can combine and actually some terms that'll cancel. If I look at this, I've got a positive x squared plus a negative x squared. Well, those two are going to cancel. I have a negative 2x plus a positive 2x. Well, those two are going to cancel. I have a positive 1 plus a negative 1. Those two are going to cancel. And I'm left with 2xh plus h squared minus 2h. So you'll see this happen pretty often in step 2 where you'll cancel a lot of terms. You'll end up with something that looks a little bit shorter and a little bit simpler than you ended up with in step 1. Again, nothing more I can do to simplify this, so we'll go ahead and move on to step 3. Step 3 says, okay, I'm going to take what I've got, which is g of x plus h minus g of x. I'm going to divide that whole thing by h. So I'm going to take what I found in step 2, 2xh plus h squared minus 2h, and divide that by h. And remember I said our goal here is to see if we can cancel that h in the denominator. There's a few different ways that can happen. The most common way that's going to happen is just by factoring. So if I look at my numerator, I can factor out an h, which will leave me with 2x plus h minus 2. And then we can cancel that h from the numerator and the denominator. So that leaves me with 2x plus h minus 2. Again, I've canceled that h. There's nothing more I can do to simplify that. So I'm ready to move on to my 4th and final step here. Step 4 says go find the limit as h approaches 0 of this function. So I'm going to take the limit as h approaches 0 of what I ended up with last time, which was 2x plus h minus 2. So 2x plus h minus 2. Now, if you've been simplifying along the way and you canceled your h in the denominator, just like I said we should, this limit should be pretty straightforward to evaluate. I'm just going to plug 0 in for h. I end up with 2x plus 0 minus 2, which is just 2x minus 2. That is my derivative, g prime of x. So that was a pretty long process, but it's the only way that we have to find derivatives for right now. So there will be some problems where, yes, we do have to use this 4-step process to find the derivative, to find g prime of x. So take your time with these problems, be careful, make sure that you're simplifying along the way, and you should end up with the derivative. And your derivative, I should mention, will look like a function. It will look like an equation. So I ended up with 2x minus 2. Your derivative is not just going to be a number most of the time. So that's how we find the derivative using the four-step process. In the next video, I'm actually going to use this derivative to help me do some cool calculus things.